The world is truly an amazing place, and the reality we find ourselves in is often too astonishing and complex for our simple minds to fully understand. Having to wrap your mind around the theory of evolution, for example, where natural selection throughout billions of years resulted in all the living species that we see today, and all the species that have ever existed. What about the thought of your own existence? The unbelievable chain of events that led to your being? Or perhaps the thought of the incredible size of our universe and the somewhat mystic physical laws that govern everything that exists within our cosmos? Our minds didn't develop to understand these things. It can therefore be challenging to appreciate the full concept of it. In this video we will try, and we will start off by looking at our family tree. Imagine a picture of yourself that lays on top of a very tall stack of other pictures. Underneath the picture of you is a picture of your father, and underneath the picture of your father is a picture of your father's father, your grandfather. Underneath that picture is a picture of your great-grandfather, and then comes your great-great-grandfather. At this point you probably have no idea who this person is and what this person would look like. The more pictures you remove from the top of the stack, the deeper down you go into your family tree and the less you know about the individual you are looking at. Because of fossils and by systematically comparing DNA, the scientific method can relatively accurately account for most of your family tree, going all the way back to your 185 millionth great-grandfather, which makes the stack of pictures 220,000 feet high. That's more than 180 New York skyscrapers standing on top of each other. If you remove the first 803 pictures from the top of the stack, you would look at your 800th great-grandfather who lived approximately 20,000 years ago. The person you're looking at would, just like you, be a human being, a Homo sapiens. But his way of life was completely different from yours, for he was a hunter-gatherer, living each day foraging and hunting, providing for himself and his group, most likely including your 800th great-grandmother. If you now remove enough pictures to look at your 50,000th great-grandfather, winding the clock back to 1,800,000 years ago, you will begin to see a notable difference in appearance. He would have a bigger head, with a thicker skull, with no chin and a prominent brow ridge. Also, his brain would be half the size of yours. He would belong to the human species called Homo erectus, a species that walked the planet for at least 1.5 million years, making it by far the longest survivor of all human relatives. You go back further to your 250,000th great-grandfather living approximately 6 million years ago, you will see a picture of an ape. Close to being a chimpanzee, but not quite. They were the ancestors that we share with chimpanzees. You continue to remove pictures from the top of the stack, and you now reach the picture of your 1,500,000th great-grandfather, living approximately 25 million years ago. Here you will be looking at a picture of what we could call a monkey, but it isn't exactly like a modern-day monkey. It still has a tail, however, and traces of that same tail can be found on your body, where the tail used to be, just at the end of your spine. There lies your tailbone, which is now rendered useless given that we humans don't have tails. It is, however, one of the very cool evidential factors for the theory of evolution that we can directly observe on our own body. Okay, back to the stack of pictures. You now remove enough pictures to look at your 7th million great-grandfather, living approximately 63 million years ago. Your 7 millionth great-grandfather looks somewhat like a lemur or a calaco. If you remove a big chunk of pictures, all the way down to the picture of your 175 millionth great-grandfather, living approximately 340 million years ago, you will see a picture of what looks like a newt. The species you are looking at eventually became the grand ancestor of all newts and frogs. You now reach the end of the stack of pictures and you're looking at the final picture, which is a picture of your 185 millionth great-grandfather, who lived approximately 417 million years ago. At this point, you are looking at a picture of a fish. That's right, your 185 millionth great-grandfather was a fish, and so was your 185 million great-grandmother. Now, in reality, the stack of pictures should be much taller than 220,000 feet high. But beyond your 185 million great-grandfather, our knowledge simply begins to fade, since we are no longer able to find fossils. But it is a fact beyond all doubt that we are all cousins. We know that, when given enough generations, ancestors that look like newts can change into descendants that look like frogs. Given even more generations, ancestors that look like fish can change into descendants that look like monkeys. Given yet more generations, ancestors that look like bacteria can change into descendants that look like humans. This is exactly what happened, and this is the kind of thing that has happened in the history of every animal and plant that has ever lived. So your ancestors reached from the very first living organism, which would be some kind of a bacterium approximately 3 to 4 billion years ago, to the living beings that you today would call your parents. And if just one of these ancestors throughout these billions of years didn't reproduce at the time that they did, perhaps because they never got to meet each other, or one of them just made a bad first impression, or the water was simply too cold for conceiving, well, then you wouldn't be here. At least not the you that you are. It is not just about the chances of your parents meeting each other, and also the probability that they actually stay together long enough to have kids. You can also include the odds that the one egg met the one exact sperm that produced you, and at this point the chances of you existing is already 1 in 400 quadrillions. But we cannot just stop there, because we have to include the same calculation for each and every one of your ancestors. The fact that they all lived to reproductive age, met each other, and had the right sperm meet the right egg for every single one of those ancestors is a supremely unlikely and utterly undeniable chain of events that ultimately led to you. The author Ali Binazir attempted to calculate this by adding up most of these factors. Of course, asexual reproduction of some of our most ancient ancestors, bacteria, is not included, since they reproduce with binary fission or cell division and therefore doesn't require a mate. The calculations resulted in a 1 in a 10 to the power of 2,685,000 chance of your existence. To put this number in perspective, the amount of atoms in an average body of 80 kilograms contains 10 to the power of 27 atoms. The number of atoms making up Earth is about 10 to the power of 50, and the number of atoms in the known universe is estimated at about 10 to the power of 80. Another way to think of it is if you imagine you have a dice with 1 trillion sides to it, and for each time you roll the dice, you land on the exact same number, 2 million times in a row. The chances of that happening, the odds that you exist, are basically 0 or infinitely low. Furthermore, the chances of our entire species even existing are extremely low. When including the entire history of living beings on this planet, there are endless amounts of things that went exactly right in order for us human beings to live and thrive on this planet. Not necessarily good things only, but also horrible events which cleared the way or somehow made it easier for our species to arise. Take, for example, the 6-mile-wide asteroid known as the Chicxulub impactor, which struck Earth approximately 66 million years ago and ended the 180 million year-long reign of the dinosaurs. Without this, the small shrew-like mammals, which were the ancestors of the Rift Valley apes and all humans, may never have flourished. Perhaps the world would still be dominated by dinosaurs and their descendants today if that meteor hadn't crashed into Earth. This is of course just one incident on our planet out of countless others, that ultimately led to human civilization. Not to mention all the cosmic accidents that have occurred since the beginning of our observable universe that resulted in our planet being inhabitable in the first place. So, to point out the obvious, it hasn't been an easy road to human domination. Mankind has on various occasions been close to extinction. Most recently around 70,000 years ago, where humanity's global population dropped down to only a few thousand individuals. One theory claims that this was due to a massive supervolcano in Indonesia that erupted, blackening the sky with ash, plunging Earth into an ice age. Other scientists aren't so sure, claiming that it might be due to a catastrophic spread of disease that almost led to our species' extinction. Whatever might have caused it, if it weren't for a few thousand of our ancestors pushing through 70,000 years ago, none of us would be here today. And again, this is just one example out of a handful that we know of where humans almost went extinct. Yet here we are, and here you are, watching this video on a giant spinning globe that orbits around an insignificant burning star and has done so for the last 4.5 billion years, inside a galaxy, the Milky Way, which contains more than 100 billion other stars. And the Milky Way is just one galaxy out of more than 170 billion other galaxies that we know of. Keep in mind, this number could potentially be far, far greater, having experts saying that there might be up to 2 trillion galaxies within our cosmos. Time for another thought experiment. Imagine we shrunk down planet Earth to the size of a grain of sand. 1.5 centimeters away from us orbits the Moon, which is barely a visible speck of dust at this scale. The Sun, about the size of a pool ball, is placed at around 6 meters away from the grain of sand, or the Earth. And when mapping out our solar system at this scale, including Pluto at the very edge of our solar system, the diameter of our solar system is roughly 464 meters long, making the entire solar system bigger than 4 football fields all placed end to end, with a pool ball-sized sun in the center of it. At this scale, with Earth being the size of a grain of sand, the observable universe would be a whopping 46,375,000 kilometers in diameter. That's equivalent to walking around the Earth 1,157 times in a straight line. Or wait, my mistake. That's just covering our own galaxy, the Milky Way. At this scale, with Earth being the size of a grain of sand, we can't even begin to conceptualize the enormous structure of our universe, so we will have to go smaller. Therefore, let's imagine that our solar system, including Pluto's orbit, is the size of a grain of sand. At this scale, the observable universe would be around 37.2 million kilometers in diameter, equivalent to walking around the Earth about 928 times in a straight line. When walking non-stop at a pace of 5 kilometers an hour, it would take roughly 849 years to walk this distance, at a scale where our solar system is shrunken down to the size of a grain of sand. Obviously, even with this scale, the enormous size of our universe is hard to conceptualize. So let's go smaller one last time. This time we imagine that our galaxy, the Milky Way, is shrunken down to the size of a grain of sand. At this scale, the observable universe would be roughly 372 meters wide, making it as big as the Empire State Building, and our galaxy being nothing but a grain of sand inside this enormous and expanding building. At this scale, light would have to travel 2.5 million years just to cover 1 centimeter in radius, hereby reaching our closest neighboring galaxy, Andromeda. Okay, so now that we have established that the observable universe is a rather large place, we can begin to cover some of the physical laws that govern it. The fundamental physical constants, such as speed of light in vacuum, the gravitational constant, the electric constant, Planck's constants regarding quantum mechanics, and the elementary charge are all observed to be somewhat improbable. If the values of any of these certain free parameters in contemporary physical theories had differed only slightly from those observed, the evolution of the universe would have proceeded very differently, and life as we know it may not have been possible. So somehow the physical laws that govern our universe are exactly optimal in order for life to prosper. This is of course rather obvious, because how else would we be here talking about it? What is noteworthy, however, is that if any of these laws for some reason had been slightly different, life as we know it, perhaps life altogether, could never be possible. A completely cold and dead universe. Physicist Paul Davies has argued, "The conclusion is not so much that the universe is fine-tuned for life, rather it is fine-tuned for the building blocks and environments that life requires." The argument that the fundamental physical constants are exactly optimal for the building blocks and environments that life requires is a problem that gives rise to quite a few theories. One of which is that the universe and the physical laws within it are designed. The designer theory, often referred to as God did it, is therefore widely used by religious people when trying to explain the origins of the universe and when trying to legitimize the idea of a God. There is, however, one major fallacy with this explanation, which is that it is not really an explanation at all. Because if you invoke a supernatural creator to explain the universe, you are left without an explanation for that creator or God itself. You are merely adding one problem onto another. Therefore, another theory that seems to be more acknowledged amongst scientific thinkers is the theory of the multiverse. The multiverse theory suggests that the reason why our universe seems so fine-tuned for life is that our universe is merely one universe amongst multiple, perhaps even infinite. Each one of them with its own laws of physics, its own collection of stars and galaxies, if stars and galaxies can even exist, which is of course dependent on the physics that govern the individual universe, and so only those universes with physical constants that make it possible for life inhabit life, and we just happen to be living within one of those universes. You can think of it as a type of natural selection amongst universes. The reason why physicists say our observable universe is because there is so much that we can't yet, and perhaps never will be able to observe. The multiverse might be one of those things. Of course, it can also be true that our cosmos is all there is, and the fine-tuned physical constants that make the building blocks and environments that life requires are nothing but a very lucky coincidence. It seems improbable, but not impossible. Nobody knows for sure. So, let's dig into something we do know, something that has to do with the stuff that you are made of. Stars. Stars function somewhat like nuclear reactors, given that they turn elements into other elements. When the Big Bang occurred approximately 13 or 14 billion years ago, only the lightest elements existed. Elements such as hydrogen, helium and lithium. When the first generation of stars formed, they then formed as lumps of gas that drew together and eventually began to combust. This first generation of stars produced our cosmos' very first heavy elements due to the nuclear reactions that occur inside of the core of the stars. This process is called nucleosynthesis, and this is a process that continues on until the star eventually runs out of fuel. And when this happens, and the star is big enough, it will collapse under itself due to its extreme gravitational pull, because it is now lacking the force and energy within its core generated by the nucleosynthesis process. The collapse results in an extreme and spectacular explosion called a supernova, and it is here all the heavier elements generated inside are swept out into space, hereby seeding the next generation of stars. This new generation of stars can then form from those heavier elements, which results in a new generation of stars that generates even heavier elements. This constant reprocessing of elements is called galactic chemical evolution, and it is because of this chemically evolutionary process that we exist. Nearly all of the elements that your body consists of were made in a star, and many of the elements that you consist of have come through several supernovas. Perhaps a tiny bit of you, the hydrogen, which makes up roughly 9.5% of your body, could potentially have originated from the Big Bang. The point is that you are, and we are all, the product of the universe's doing. Everything you see, everyone you know, and yourself included, are all made of stardust. Think back to when we conceptualized the enormous structure of our observable universe, which is beyond all ordinary human understanding. All of the mystic physical laws that govern it. How amazing it all seems to be. Well, so are you, and so are all of us. We are made entirely of the same stuff that the universe is made of. Therefore, we are the universe. The astronomer Carl Sagan once famously said, "The cosmos is within us. We are made of star stuff. We are a way for the cosmos to know itself." Another way to put it is that we are the universe experiencing itself. On this note, I would like to finish off this video with a quote from the philosopher Alan Watts. "Through our eyes, the universe is perceiving itself. Through our ears, the universe is listening to its harmonies. We are the witness through which the universe becomes conscious of its glory, of its magnificence." Thank you for watching. I hope you liked this video. Let me know in the comment section below which chapter you found the most compelling. If you would like to watch more, make sure you hit the subscribe button and give the video a thumbs up. See you in the next one.